So do you see when we are dealing with transition metals, we have got two types of iron chloride, iron 2 chloride, iron 3 chloride. How do I know this is Fe plus 3? I look at the charge of its partner, which is -3. In this case, 2 chlorine -2. The charge of Fe is +2. That's why I put Roman numeral 2. That's why here I have Roman numeral 3. Lower charge, ferrous chloride. Higher charge, ferric chloride. How about this one? Separate non-metal from metal. Look at the group number. Bromine is in group 7A. See how far it is from 8? -1. That's the charge of bromine. How many bromide? 4. Charge of each, -1. Total charge, -4. So what should be the charge of lead? +4 adds to -4 to be 0. So I call this lead 4 bromide. And it's called plumbic bromide because it's 4 is the higher charge. Lead can be +2 or +4. If I go to the next slide, see if you can name these. Use the systematic method, which is using Roman numerals. It's easier. Go, guys. Let's see if we can do it. I want to see who gets it the first. Who's the first one? Who's getting this? Christina, killing, good job. You're the first. You are getting it, guys. Good job, guys. I see you're paying attention and you are learning. Do these make sense to you? Guys, go ahead, ask a question. I see some of you did not respond. Ask a question so I can explain. What is it not clear to you?
So basically, are you doing the process of checking with the group number and then subtracting it from 8, the octet, to make sure you get your charge, and then you multiply it by how many you have there, so you would get whatever that charge is on the right side, and on the left for sulfur, and then on the left side for iron you have 2, and you know that iron is a plus, I don't know what iron is. Iron is plus something, but then you basically make sure that they balance each other out, and then however many. Exactly. I don't understand.
Yeah, go ahead.
Where do you get the third? Why is it iron 3 instead of iron 2 when you only have 2 irons?
Let's do that together again. So this is Fe2S3. Step number 1, separate metals from non-metals. How do you know Fe is metal and sulfur is non-metal? You have a periodic table, and periodic table are color-coded. By looking at that, look at the color coding, you know this is non-metal. This is a non-metal. Non-metal. And you know iron is a metal. So you use the periodic table to decide. Draw a line between them. For non-metals, we said, look at group number. Sulfur, is it 6A? If it is 6A, how far is it from 8? For non-metal, it's -2. So total charge of the non-metal, there are 3 of them, -2, each total of -6. Yes or no? So first determine the charge of non-metal, because it's fixed. The charge of metal is a transition metal. It can change. That's why I first determine the charge of the part which is always fixed. Then I can calculate the unknown charge of iron. So if you write X, charge of iron, plus charge of 3 sulfur is adding to 0. So what is the value of X? Can I move 6 from left to right? So it becomes 0 plus 6. Do I get 6? So the total charge of 2 iron is 6. What is the charge of 1 iron? Plus 3. That's how you know. So a simple algebraic equation. We want to make sure we know this charges of positive and negative in an ionic compound must add up to be 0.
So how come it wouldn't be iron 6 sulfide then, instead of the iron 3?
Yeah.
Is that because you're only accounting for the 1 iron instead of worrying about 2?
No. How many iron do I? Let's do this one. Do I have 3 times -2, which is -6? So what is the charge of the other partner? Plus 6, right? This would have been 6. This is not 6 because you have 2 of them. Total charge of 2 iron is 6. What is the charge of 1 iron?
3.
Does it make sense?
Yes.
Perfect. So this doesn't exist actually, because iron would never have plus 6. Based on experiment, we know it's either 2 or 3.
Oh, because we're just finding the charge of the iron.
Exactly.
Oh, okay.
Charge of 1 iron. And the charge is inside Roman numeral. We show the charge.
Got it. Sorry, I interrupted whoever was talking.
No, that was, I bet you helped a lot of people. But that was a common question and nobody asked but you. Yes, go ahead. Somebody else had a question.
So because we had 2 of the irons, so it's 2 times 3 is what gives it the 6, correct?
Excellent. Yes. Yes. Perfect. But we want to calculate charge of 1 iron, not 2 iron, not 3 iron. Let's go, you go out to restaurant, you eat together. And there is 2 of you. And you're pitching in. So you divide the whole charge between the 2 of you, divide by 2, so every person is paying so much. Charge per atom, charge per person. Does this make sense? Okay. So go guys. See if we can do these one now. Oops.